Good evening, everyone. Tonight's video is 13.2 and it's algebraic representations of dilations. When a dilation in the coordinate plane has the origin as the center of dilation, you can find points on the dilated image by multiplying the x and y coordinates of the original figure by the scale factor. If you notice, you see the term factor, and remember that factor, when we're talking about math, is one of the numbers in a multiplication problem. So when you've been given a scale factor of k, and briefly I discussed in video 13.1 that k is the constant. So when you've been given that scale factor, that means algebraically that x is being multiplied by k and y is being multiplied by k. If k is greater than 1, that means you have an enlargement. If k is smaller than 1, meaning it's a number between 0 and 1, you have a reduction or a smaller image or a smaller figure. If k is 1, you have the exact same figure because anything times 1 is itself. Let's look at the first box. We have a triangle with vertices A located at 0, 3, B located at 4, 1, and C located at 5, negative 2. We're going to write an algebraic representation for this dilation. Then we're going to determine the coordinates of the triangle after a dilation with a scale factor of 4 has been applied. So algebraic representation, what that means is you'll take the scale factor 4 and multiply it times x. You'll take the scale factor 4 and then multiply it times y. So each coordinate within that order pair has to be multiplied by the scale factor. So that's one way we can write it. We can also write it as 4 times x, and we can write it as 4 times y. So that is the algebraic representation. Now let's apply it to those points to see what the new location would be. So I'm going to take the 4, which is my scale factor, and multiply it times 0, and then 4 times 3. 4 times 0 is 0, and 4 times 3 is 12. So A prime is located at 0, 12. Then I'm going to take the x coordinate of 4, multiply times my scale factor of 4, take the y coordinate of 1, multiply times my scale factor of 4. 4 times 4 is 16, and 4 times 1 is 4. So the new ordered pair, or the new location for B prime, would be 16, 4. Next I have C. So I'm going to multiply the scale factor 4 times 5, and then I'm going to multiply the scale factor 4 times negative 2. I just like to write my negatives first, and remember, whenever you're multiplying, if that's the only operation you are performing, it doesn't matter what order you multiply in, you're going to still get the same answer. So 4 times 5 is 20, just as 5 times 4 is 20. And then I have a negative 2 times a positive 4, which gives me a negative 8. So the coordinates of the triangle after the dilation of the scale factor 4 to A gives me A prime 0, 12, B prime, which is 16, 4, and C prime, which is 20, negative 8. Take a moment, pause the video, and work the box on the back by yourself. Then begin the video back up to see if you are working it the correct way. Okay, so we have a triangle with vertices A located at 0, 4, B located at 4, negative 2, and C, which is located at 6, negative 8. We need to write an algebraic representation for the dilation. Then we're going to determine the coordinates of the triangle after a dilation with a scale factor of 1/2. And because my scale factor is between 0 and 1, I know that this is a reduction. So let's begin with the algebraic representation. You can write it as 1/2 times x, or 1/2 times y. You can also write it as 1/2 times x, or 1/2 times y. Another way you could write this would be 0.5 times x, or 0.5 times y. Now let's apply our scale factor to each coordinate. to get our new point. Okay, so I have a half times 0, and then I have a half times 4. So 1/2 times 0 is 0, and 1/2 of 4 is 2. Then I have 1/2 times 4, and I have 1/2 times -2. Well, I know 1/2 of 4 is 2, and 1/2 of -2 is -1. Then I have a half times 6, and I have a half times -8. So I know 1/2 of 6 is 3, and 1/2 of -8 is -4. So the coordinates of the triangle after the dilation are: A prime is 0, 2, B prime is 2, -1, and C prime is 3, -4. That will do it for this video. Please let us know if you have any questions tomorrow when you come into class. Enjoy your evening.